Dear students, how are you? Hopefully you are fine. Today I am going to discuss about an important element of a topic of organic chemistry, which is called isomerism. Let's know about isomerism. You have already studied about isomerism in different topics in organic, inorganic chemistry, or also organic chemistry. There are various types of isomerism, such as functional group isomerism, other one is locational isomerism, chain isomerism, and geometrical isomerism, optical isomerism, and next one is metamerism, and the last one is tautomerism. So, if we want to know the first isomerism, which is functional group isomerism, first we have to know there is ROR, which is called ether. You know about ether that R means alkyl, and there are at least two numbers of alkyl which is with oxygen, and it's called ether. So if we use methyl, the first member of alkyl, and there is also another methyl, that will be said dimethyl ether, dimethyl ether. And if we notice here C2H6O, and if we describe it here, there will be CH3, oxygen, CH3. So methyl, and here is also another methyl. The number of carbon is 2, C2. The number of hydrogen is H3 and H3. That means 6H. There are 6 hydrogen. Here is also H6, and there is only one oxygen, and here is also one oxygen. It means it's an isomer of this compound C2H6O. And again, if we write CH3, CH2, and OH, you know that it's called alcohol, OH, which is called alcohol. And there is also the same number of carbon, hydrogen, and oxygen. So the difference is in what? The difference is in functional, which is called functional group isomer. So ethanol and dimethyl ether is called functional group isomer because of there is the difference between functional group. One is alcohol and other one is ether, and that is called functional group isomer. Next, locational isomer. So there is a difference between location of any group. Let's see, CH3, CH2, CH2, OH. And what is it called? Definitely you will say it 1, 2, 3. So, and there is an alcohol, and it's called propyl because of 3 carbons. And finally it will be said propyl alcohol or propanol. So alternatively it will be said propanol 1 because of we have to count it from here 1, 2, 3. Since the alcohol is situated in one number of carbon, that's why it will be said propanol 1 or 1 propanol. Again CH3 CH3 and here will be alcohol. Again the number of carbon is 3, here is also 3. The number of hydrogen 3, 2, 5, 5, 2, 7, 7, 1, 8, 3, 3, 6, 6, 1, 7, 7 and 1, that means 8. So number of carbon, number of hydrogen and oxygen is same here and there. That's why the difference of location of alcohol, it will be said 1, 2, 3. So you can say propanol 2. So alcohol is situated here in number 1 carbon, but here is in number 1, number 2 carbon. That's why it will be said propanol 2 and propanol 1 depending on the location of alcohol. Here 1 and here 2. Okay. Next, so we can understand that it's called locational isomerism, depending on the location of alcohol or any group. Okay. Next, chain isomer. If we write firstly CH3, CH2, 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 CH3, CnH2n plus 2. You have already known about alkane. C5H2 into 5 plus 2. So C5H2 5 is 10, 10 plus 2, that is 12. So it should be said pentane. And since there is a simple chain, that's why it should be said N-pentane. N-pentane. And next CH3, CH, CH2, CH3 and CH3. So here is also the number of carbon is 5 and here is also number of carbon is 5. Then it will be said N-pentane and it will be said isopentane. Isopentane. Because of there is a difference of just chain. It's simple, but it's not simple because it has already a branch. So you can say it isopentane, but the number of carbon is same, the number of hydrogen is same. So you can say it isopentane. Next, C is 3, CH3, CH3 and CH3. Again, the number of carbon is 5. You have already noticed, and the number of hydrogen is 12. That means it's also pentane, but it will be said neopentane. Neopentane. Okay. So there is a difference of chain. That's why it's called chain isomer. They are mutually chain isomer, and it's called chain isomerism. Next one, you can understand about the isomerism today. Our next topic is geometrical isomer, and you will know about geometrical isomer. CH3, CH, CH, CH2, and it's called butene 1, and CH3, CH, CH3 and CH3. So you will understand easily that what am I saying? That it's built into 1, 2, 3, 4. 1, 2, 3, 4. The double bond is in number 1 carbon. That's why it will be said built-in 1. The double bond is in carbon 2. That's why it will be said built-in 2. Okay. If we check it here, C double bond C, and there is a hydrogen, and here is also a hydrogen. These 2 hydrogen here, and that will be CH3, and here is also CH3 methyl. So since there is same group, that's why it should be said cis butene 2, cis butene 2, and CH3 hydrogen, and here is hydrogen. So you can easily notice the difference of the location of same type group. There is methyl, but there is hydrogen, and there is methyl, and here is also methyl. So the relation is very clear here. It's straight, but it's not straight. Okay, so that will be say trans butene 2. So that's why it's said geometrical isomerism or cis trans isomerism. Next one. Optical isomerism. Optical isomerism. Know that it's related to light. Optical isomerism is also dependent on carbon. You can say it what? 1, 2, 3. So definitely will be said 2-hydroxypropanol. What? 2-hydroxypropanol, because of alcohol is situated in carbon 2, and there is also the priority of aldehyde group. That's why it will be said 2-hydroxypropanol. If I write it like this: alcohol, hydrogen, and aldehyde, and methyl. Notice one thing, that there is 4 different groups in the 4 hands of carbon. That's why it's called chiral carbon. It will be said chiral carbon. So again I am saying that when there are 4 different groups in a carbon of 4 hands of carbon, then this carbon will be said chiral carbon, and this star mark means this is chiral carbon, and it's called chirality. It's called chirality. So what will be happened if you take a mirror here? Then just will work like CH3. It will go here, hydrogen, and this alcohol will go here. If you write it clearly, that will be alcohol here. So it's called dextrorotate. It should be levorotate. If it goes like 45-degree angle plus 45 degree, then it will be like minus 45 degree, and they're called mutually enantiomer, and their mixture is called racemic mixture, and shortly it's called optical isomer. Okay, and this is for optical isomerism. Next, there is the matter of tautomerism, the sixth number, isomerism. Tautomerism, if we write here C3, C double bond to C3, you know that it's called propanone, dimethyl ketone or acetone, whatever you say. It works like that. If we take acetone like it, if the double bond of carbon and oxygen breaks, then there will be a necessity of filling this hand, also carbon. So if we write here C3 just like C2 and H, and this hydrogen will get the chance to take bond of oxygen, and it will be just like OH, and it will be alcohol. And since there is also a lack of a hand of carbon, this carbon, that's why it will be created here a double bond. And you can easily notice that there is also alkene, means double bond, and there is also alcohol. That's why it will be said prop 1 in 2 all. Propene 1, that's why here is prop 1 in, and the alcohol is situated in 2 number alcohol. That's why it has been said 2 all. All means the short form of alcohol. And there is also ketone. So keto ENOL, ketoenol, and that means it's said ketoenol tautomerism, and shortly it's called tautomerism. The next one and the last one, metamerism. Metamerism, depending on double valence group, such as CH3, C double bond O, CH2, CH2, CH3. It's called pentanone 2, because of the ketone is situated in number 2 carbon. That's why it's said pentanone 2, and it has the valence of 2 ketone, that is also called carbonyl group. And if you write here C3, CH2, C double bond O, CH2, CH3, and it will be said differently pentanone 3. So pentanone 2 and pentanone 3 is mutually metamer, and the characteristics is said metamerism. So today, that's all for today. That is depending on isomerism. Hopefully, dear students, you will be helpful and very confident watching this video class, and I think that you will insist on organic chemistry to get a better result in your all type of examination. Thank you.